So this is about where I teach you Sui Move in 15 minutes, and if I can't, I failed you. You always have Sui by example.com to view snippets and examples for projects and all of that stuff. That said, I'm going to reboot my terminal and create a new Sui Move project. As you can see here, I use the Sui Move new Sui by example command to create a new project. And I've opened that in my VS Code, right? So you can see, I'm not going to be following through with this. I'm just going to remove this, and yeah, now I'm in VS Code. And you can see that I've opened the project right here. I'm just going to show you what the directories look like currently. We have our Move.toml, our package manifest, and we have our test directory, and we have our sources directory where this right now our code. So let's just dive right into that. Now, the first thing you want to do when you create a new Move project is actually to define a module, right? And so you do that with the module keyword, then you follow it up with the package name. So in this case, it's Sui by example, and then you're going to specify the name of the module you're creating. So in this case, let's do human, and then you can close it off with a brace, or you could encapsulate everything in the module with curly braces. Yeah, so I'm just going to remove this, and then the first thing you want to always do a lot of times actually is to define your structs, right? You can define your structs with the public struct keywords and then followed by the name of the struct. So in this case, let's do human, and then you can now add what humans can do. So now a human would have an age, and then a human would have a name. But here's the thing, strings are not first-class citizens when it comes to Sui Move, so we can expect an error here. But we could always import it from the standard library with the use keyword. So now you know how to import things with the use keyword. You easily just specify the namespace and then you can access it, right? That said, another thing you want to probably learn is how to declare variables, and one of them is constant. So you specify the const keyword followed by the name of the variable. Since we are doing a constant, your identifier has to be all caps. So let's do error no human, and then follow it up with the data type, and then eventually the error code or something, whatever you're trying to make constant. And that's how you do a variable. We're going to be seeing more variables very soon. Another thing you want to learn is how to declare a function. You're going to be using the public keyword again. And then there are two types of functions. There are entry functions and non-entry functions. So your entry function can be called from anybody, so with clients, and everybody out of the program can access it. But if you do not have this entry keyword, only you and your program will be able to call this function, right? Only the owner of the package will be able to call the function. And so I'm just going to leave that for now, and then followed by the fun, which is like what we call functions, and then the name of the function. So in this case, we want to create a human, right? And now we just enter what the human should like have. So basically pretty much what the function accepts, right? Function can accept stuff. So in this case is an assigned 8-bit integer, and then of course the name again. And then this is a string. Now functions can actually return stuff. In this case, we want our function to return a human. So when a person specifies the age and the name, we want to return a human back to them. And then we can always just specify the human type and then open this. But then we are presented with a very beautiful error, a very good one at that. You see, the entry has an error because it does not have the ability of drop. So we need to add the drop ability. But what are drop abilities? Abilities are things that allow objects to do more stuff. And this is actually an object. And almost every asset on Sui, actually every asset on Sui is an object. So we can just easily specify the ability with the has keyword followed by the ability you want to create. So in this case, we want to create a drop ability. There's also the copy ability and there's the key ability, but we're not using those for now. Just focus on the drop ability for now. And now see everything works. We no longer have that error anymore. And now we can always declare a variable or an instance of the human object, right? So we could do let's goodness, for example, be equal to human, and then specify the details of the goodness that are human, right? So the age would be age, and then the name would be name. We're getting an error because that is not a return statement. So once we specify the return statement, in this case goodness, everything works as fine, and you do not have to include curly braces in your return statement. That said, another thing you want to learn is actually conditionals, right? And you specify a conditional with the if keyword followed by the expression in brackets. So we do if goodness.age is greater than 18 or 19, then we want to specify a condition that should run. So let's just return goodness in this case. And then else, let us return goodness as well again. And so that's how you do conditionals. Another thing you have is loops, right? So you have the while loop and the loop loop. The loop is actually the easiest. It's just a loop that runs indefinitely, right? And then the while loop using an expression. So you specify your expression in curly braces. So let's goodness.age is greater than 18. Then you specify the condition in between the braces. And that's how you do a while loop. Another type you'll be using a lot is vectors. You use vectors to store things that are all the same type in a list, right? And so to define a new vector, you don't have to import anything. Just simply initialize the variable like this. So let's say we wanted to do human ages, right? So let's human ages, and then you also have to specify that it is a vector. So vector, and then empty. So in this case, we are specifying that it's an empty vector we want to create first. And of course, before that, you have to specify the data type. So let's just do a vector of unsigned 8-bit integers and then close that off. And then to add data to the vector, we usually use the vector pushback function to add data. And here's something you need to know. So for all data types, you could always just do this and then sprout through all the things you can use. So yes, inside there's index of, and just have all of that, right? So we're also using pushback to add something to the end of the vector, and we'll specify the vector here, human underscore age, but we need our vector to be mutable. So we'll specify mute here, and then we also have to like borrow it, right? Since we have to borrow it, right? So we borrowed the human resource, and then we also have specified the elements we want to add. So let's say we want to add 12, and that's how you add things to a vector. So remember that you can always use this to specify like any function you want and then have it. You also need to work with strings, and we've already done that before. So what you just need to do is let string name, so in this case let's use name, be equal to string, right? And then use the UTF-8 function to specify the bytes. So strings are actually bytes, and so you just have to like specify them. So in this case, I'm just going to let's need one, and then specify the string, right? So let's say the name is goodness. And so to append or access functions that you have with strings, you can also always use the string functions like this in the same way you did for vector. So we want to append something to the string. And so remember to make your string immutable if you're going to make any modifications to it. And then we can just easily do mute and then the name of the string and then what you want to append to it, right? So you also have to still do the UTF-8 thing again, specify the bytes in the UTF-8 encoding. And then, of course, just easily do this. Once again, you need only one. So specify the space name is something like that, and then that's how you actually work with strings. Another data that will probably come in handy for you is bags, right? And bags are like composite maps, or let's think about them this way. They you can store anything, you can store almost anything in a bag, and it's a key value pair, right? So it's not like regular table where you have to store or everything that has the same type. And to declare a bag, you actually have to use like the Sui library, so it's Sui bag, and that's how you get a bag. And now you can now declare a variable. So you can just do let bag be equal to bag and new bag. But here's the thing, you need the transaction context, right? And the transaction context is pretty much gives you context of the transaction, like who's the sender and a lot of other transaction data, right? And then to get the transaction context, you actually have to declare it as one of the things that your function takes in. So it's like this, and then a immutable reference to the transaction context like this. So it's TX context, right? But here's the thing. You cannot have a transaction context in an entry function. So I'm just going to remove this, and then let us also return a bag, right? So this is also return a bag, and now we can now return this bag, right? And I'm just going to do this, and yeah, I forgot to import this bag type. So I'm just going to do it here. Just you can always just do this. So it's use Sui bag and then self and then the bag type. So now everything works. You see that we've created a new bag. And of course, don't forget that you could always just do this to see all the functions that you have. So I mentioned tables without even actually telling you what tables were. And tables are a whole lot like bags, but in this case, they actually store one type. So like basically the types are premediated. They are not random. You could not easily store anything. So you have to like premediate what the key type is and then what the values type are. So I'm just going to remove these bags, and then really you actually fly by just changing this to table instead. So table, and then since the key and values are premediated, you actually have to specify them wherever you're going to declare a new variable. So in this case, we want to do a table that holds strings as the keys, and then 64-bit integers as the value. Now we have to return something. So we have to return the table that holds strings and 64-bit integers. Now to create a new table, we're going to use the table new again, similar to how we did it before. So it's table new, right? And then it takes into consideration context. But before that, we have to specify the types that we want to use in this case. And so I'm just going to like copy this and paste it here. And now we can easily return the table. As you can see, everything works, right? So that's how you work with tables. Don't forget that you always have this. I keep mentioning this because it's something that comes in handy a lot. Now there's a whole lot of other data types, but I've shown you um the most popular ones, or basically the ones that I use more often and I see in other code bases. And then it's more of a case of like I've shown you how to actually explore them as well. Because now if you're adopting any new data type, you could always just use this and then you get access to all the functions, all of that, which is really cool. Now I want us to move on to the next set of things, which is like more smart contract centric stuff. So we already talked about transaction context, but I want us to shed a little bit more light on it. So now the first thing is this. Um, Let me just clean this off and then see if you use the dot notation on this, you can see that there's a lot of things you can get from transaction context. One of the ones you'll be using a lot is the sender, right? And then the sender is like person that's sending transaction, the person that's calling this function. That's how you can access the person's address. There's also sponsor. In case of like a case of a sponsor transaction, you could always access it through that. And of course, just whenever you need to access anything that has to do transactions, you can have all of them here defined here already. And these are like all the functions, right? So there's that. Okay, so in some cases here, you'd want to create a function that runs just once. So in the case of like you're building a lending protocol and you want to declare a table, right? A table that actually holds every user's information, and then you want this table to only exist once, right? Because you don't want to always create a new table, which makes a lot of sense. In this case, you want that function to run only once. And then there's also a case where you would probably want to just create things once. How you do this is with the init function, right? And then the smart contract actually runs the init function on default once it's deployed. So the way you do this is with the fun keyword again, no public this time around, and then init. And then this function takes in two things. It takes in your witness, your one-time witness, and then your transaction context. Now, the one-time witness has to come before the transaction context, so I'm not going to include anything yet. Now, what is a one-time witness? One-time witness is this. You It's actually a struct, and it has to have the same name as your module. So in this case, as you can see here, I already removed the human struct we had before just for this, and then I'm just going to declare the struct. So it's human. Every letter has to be capital, by the way, and then just it has to have the drop ability, and then just easily open this. Right, there has to be no filter as well. And now you can now specify the one-time witness. So it's witness, human, and then of course the transaction context actually has to come last, and it is a mutable reference to transaction context. So it is the same thing we've been doing the entire time. So it's yeah, I just had to, yeah, and then tx context, yeah, and that's exactly how you do your init function. And then whatever you put in here will just run once and cease to run again. So basically anything that's here would run once, nobody else can call it, even you could not call it. So I want to show you how to work with time. So you're going to use the clock module from the Sui library. So it's a whole lot like clock, and then you could easily import self and clock. So I actually like to import self, so I don't have to do that again, because a lot of times you virtually need to do it. So I'll just be doing that, sure. And then yeah, so public fun. Let's actually just really get the current time. So current underscore time, and then it's supposed to take in a reference to the clock. So it's like this reference to clock, and then the function. In this case, now we want to get the current time. So let's just do let time be equal to clock dot the current timestamp is with the timestamp underscore ms function, and then now you have the time here. Now that's not the only thing you actually have. You can easily just do this and then access all the functions, right? So that's actually how you work with time. And then finally, let's do events. So events are like, how you basically get some reception from the server side or from your client. So let's say you wanted to monitor what's happening in your contracts, how many people are creating, how many people are creating something, how many people are doing whatever. You can usually use an event to do that. And to do that, you actually have to declare a struct for the event. So in this case, let's just really do a struct, public struct, created human. So this should trigger whenever somebody creates a human, right? And then it has to have the copy and the drop abilities. And then let's actually just return the name and the age of the human whenever a new human is created, right? And so the next thing we want to do is define the function. So this is how you actually emit the event. So it's public function. So created human. So more like create human really, because you actually won't be defining functions to emit an event. So pretty much, I mean, like emit an event in terms of like purely just emit events, that would not be happening. So yeah, let's return a human, and then now let's create a new instance of a human. So let's human be equal to human, and then let me just fill that in. So age would be age, and the name would be name. And of course, let us return the human back. So pretty much everything works. Now to make the events, you actually have to import it from the Sui library. So it's use Sui events and then emit, right? And then come back here, and then this is part where you emit the event. So you can use the emit and then specify the events you want to emit. So it's created human, and then as you can see here, I've specified what I want to emit. So basically, I'm emitting the same age and name, and then whenever this function gets called, the the events will get emitted, and then you can listen to it and do whatever you want to do with it. So that's it, guys. I tried to cover everything in these pages, except for VecSet and VecMaps, which are a whole lot of vectors, and you can just check them out. But that said, I really covered everything apart from I think VecSet, VecMaps, and generics. And I also covered everything in this advanced move aspects as well. So, if you sh- still need additional information, always visit the Sui docs. And I actually did not intend for this to be the last thing you learn. It's just for the impatient and people that want to just read the things fast. So you can always visit the Sui docs at docs.sui.io to learn more about Sui and Move. And I always recommend the Move book. Actually, that's what I used. So always visit the Move book. Easily just Google Move book and it ranks easily. So it's at the top, and just easily visit it and browse through everything for more detail. And it also helps you move fast relatively well as well. So yeah,